Hello and welcome to Web Learning, where knowledge is shared. I'm going to show you this in a minute, but just before I want to explain to you where I've gone for the past year and a half. If you want to skip this, just jump to the time that is showing now on the screen. So in the past year and a half, I couldn't load any videos. I became a full-time dad 24/7. My kid's mother passed away, and it took me some time to find the time to make more videos. I want also to thank my Patreons that were supporting me all this time. I kept on building things, and I'll start showing them slowly. As I teach my kids, something is better than nothing. And my Patreons stuck with me all this time, and they never left me. And that's it. So I'm going to show you what I've built since we talked the last time. If it's the first time you're into this channel, then have a look at the other videos. So this is an emergency battery pack that I built. It's sitting in a case. Let me close this. And it sits in my house next to a power outlet. So in emergency, I can just turn it on, switch off the mains power, and use this as a backup. I made this. We also have here a jumper cable. So if I have a battery or something, I can use this in emergency. This is a pure sine wave 2600 watts peak inverter. Usually it runs at 1300, but you can pick it up to 2600. Those batteries, each one of them, those are LiFePO 4 batteries. Each one of them is between 130 watt and 150. The back one's 150. I have 9 cells on a row, and I have 2 rows. There is another row at the bottom, and a few more batteries down here. So in total, I have about 22 batteries. All the batteries are connected through those PCBs I made the last time. I'll share a link to the video. Each one can hold up to 5 batteries, and I can either put them in series or in parallel to the main one. Now this is the main one. Now you can see that I've connected 1, 2, 3, and 4 batteries in parallel, and all of them are connected to the main one. The main one, each PCB can hold up to 30 amps. The main one needs to hold up to 100 amps. So what I did, it's hard to see now because I already put Kapton tape on this. I took a copper wire and I soldered it to one to the positive and one to the negative, and I made this kind of a bus bar. You can also use a bus bar and drilling holes to fit the XT60, and then use this as the main power supply. The power comes from the battery. Okay, I have a long cable. This is a 7AWG multi-thread wire. All the cable goes to this fuse. This is a resettable fuse. It's a 100 amp fuse, if I can focus this. What it means that you can pass 100 amps. If it's over that, it will trip, but you can always reset it back to what you want. I also use this as a switch to the sine wave inverter. I also got this little device. This is a RF power meter. It has this LCD. The LCD can be plugged to any USB port, or you can connect it directly to this device. It comes with a current meter, and I'm measuring the voltage directly on the terminals of the pure sine wave. If I would measure it in the battery, there are always losses on cables and stuff, and I wanted to see exactly what is the voltage on the power inverter. Each battery has its own BMS. That's why I'm connecting only the power cables and not the BMS itself. You can see I can still reach the BMS. All the BMS have cables out, but I didn't connect them I just connected the wires, and I'm relying on the BMS to shut down the battery if need to. So coming back to the display, it has a small RF transceiver. You can plug it anywhere in the house. As long as you have communication, you can see exactly what the battery is drawing. The way, as I said, I turned it on, I just used this power switch. If I'm going to run it for a long time, I will take out the sine wave out, because the sine wave has a fan and it also heats up. But for today's purpose, I will just turn it on in the box, because I don't want to take it out and put everything back again. Let me connect the USB here, so when I turn it on, you'll see the LCD also running. So switch it on, and that's it. Now the sine wave has power. It has an on-off switch right here at the front that I need to turn it on if I want it on. And you can see all the information on the battery. Now, I didn't set the total capacity of the batteries yet. It shows that the batteries are 26.7. This is a LiFePO 4. And this is the amount of kilowatt hour that I have on the batteries. Again, I didn't calculate it correctly. As some of them are higher, some of them are lower. This is about each battery. I can calculate around 130 watt. So this whole case should be around 3000 watt, just a little bit less. You can see that there is a RF connection and it's fine. And also when the system is running, it will tell you how long you have power with the amount of draw that it has on the system. So this is like 70 days, 23 hours, 54 minutes. And when the system starts to run, it will tell you how long you still have power before it shuts down. But it all depends on how much kilowatt hour you have set it up in the system. So that's it. If I want to turn it off, I just click the button, and that's it. It turns off. That's my system. I hope you like it. Don't forget to subscribe. Hopefully I'll load more videos very, very soon. Take care, and thank you everyone.